So this video just follows on from the video where we derived the other 3 formulas. So now we have a total of 5 formula that we are going to be able to use for these questions. So example 7, a particle is moving along a straight line from A to B. So it's going from this point here, A, over here to B, and constant acceleration of 5 meters per second. And because it said constant, that means I know I can use those suvat equations. So the acceleration is 5 meters per second squared. The velocity of the particle at A is 3 meters per second, and it's in direction A to B. So I know that it's going from A to B at 3 meters per second. The velocity of the particle at B is 18 meters per second in the same direction. So it's still going that way, 18 meters per second. Find the distance. So we're looking at the distance from A to B. And just like we approached those last example questions, I'm going to write out what I know. So if I write out suvat, and I can fill in the bits that I know. So I know the acceleration, that's what they told me was 5 meters per second squared. I know the initial velocity, that's 3 meters per second. And I know the final velocity, 18 meters per second. And I'm looking for the distance. I'm looking for S, that's my question mark that I'm trying to work out. Now, I know I'm going to need to use the formula that includes all the letters apart from T. I don't know T, and I'm trying to work out T, so that's the only one that I don't need. So if you look through these formulas that we've got, this one here is the only one that doesn't include T. So I'm going to use V squared equals U squared plus 2AS. Now I'm trying to find S, so I'm going to rearrange for S. So S is equal to, take U squared over, so V squared minus U squared, and divide by 2A. And if I sub in then the numbers I've got, so I know that V is 18, so I've got 18 squared minus U, which is 3 squared, all over 2 times, and 5 is the acceleration. Type that into your calculator and you should get an answer of 31.5 meters. So that's my answer there. The distance from A to B is 31.5. Okay, let's move on there to example 8. Let me just do that. So example 8 says a particle is moving in a straight horizontal line with constant deceleration of 4 meters per second. Now if I'm going to draw this out, I know it's using O and A, I've just looked ahead in the question. Now it's a deceleration, so I'm still going to draw my arrow this way, because decelerating will be negative 4 meters per second squared is the acceleration. If it's decelerating, that is negative acceleration. At the time t equals 0, the particle passes through the point O, my initial point, with a speed of 13 meters per second towards point A. So 13 meters per second is my velocity there. And OA, the distance from O to A, is 20 meters. And the first thing is finding out the times when the particle passes through A. So let's write out again what we know. We've got S, U, V, A, and T. Well, S is the distance to A, which is 20 meters. U, the initial velocity, is 13 meters per second. I don't know V. And I do know A is negative 4 meters per second squared. And it said here, find the times. Now that's because, as you'll see when we solve this question, there will be 2 times that the particle goes through A. The particle is going in this direction, but it is slowing down. At some point, when it has slowed down so much, the direction of velocity will change and it will start moving backwards in that direction. So it will pass A on its way forward, but it will also pass A way backwards. So let's have a look. I've got S, U, and A, and I'm trying to find T. So if I look at these formulas, I'm going to use formula 4, because that is the only one that does include V. So S equals UT plus a half AT squared. And let's put in the values we know. So S is 20, U is 13, I don't know T, so I'm going to leave that as a T, plus a half A, so a half A being negative 2, T squared. And what I got here, if I just rearrange that, 2t squared minus 13t plus 20, is I've got a quadratic, and I'm solving a quadratic. Now you could want to put it into brackets. I'm just going to solve it using my calculator. So using the quadratic function on my calculator, I get that t is either 2.5 seconds or t is equal to 4 seconds. And like I said before, both those answers are answers, because it will go through A on the way there and through A on the way back. So it goes past A after 2.5 seconds, but also past A after 4 seconds. So they are both my final answers. Part B asks for the value of t when the particle returns to 0. Now, For part B, I'm going to need to write out what I know again, because some things have changed. This time, the initial velocity is still 13 meters per second. The acceleration is still negative 4 meters per second squared, but the displacement isn't 20 meters. I'm not interested in point A anymore. I'm interested in when it's back to point O. And that will be when the displacement is 0, because it hasn't moved relative to its original position. It has gone out and come all the way back again, but the displacement is therefore 0 meters. And I'm trying to find the time. So again, I'm going to use s equals ut plus a half at squared. And if I sub these values in, I get that 0 is equal to 13t minus 2t squared. And solving that on your calculator, you will get that t is equal to 0, or t is equal to 13 over 2, so 6.5 seconds. Now, I know that t is equal to 0 is when the particle was first at O. That's when the whole thing started, when the particle was at O. So it must have gone out and come all the way back, and is back there at 6.5 seconds. So when the particle returns to O, the time is 6.5. So I will say particle returns to O at 6.5 seconds. So 6.5 is my answer there, 6.5 seconds. Okay, then we're going to final example is example 9. So this one says a particle P is moving on the x-axis with constant deceleration. So I'm going to again draw it out. I've got the particle here moving along and it's decelerating, which means the acceleration is just negative 2.5 meters per second squared. At time t equals 0, the particle passes through the origin O. So this is the origin O, I'm going to say here, where the particle is at t is 0. And it's moving in the positive x direction, so it's moving along the x-axis at a speed of 15 meters per second. Then it says, find the time between the instant when P first passes O and the instant when it returns to O. So let's think about what we know. If I write out the suvat numbers again. The acceleration is an easy one to fill in. It's negative 2.5 meters per second squared. The initial velocity is 15, that's what they gave us in the question. And there must be one more thing that I know. Well, I'm looking for when it returns to O. And if it returns, that's very similar to in example 8 that we just did. The displacement will be 0 meters because it has gone out there, all the way out, and turned around and come right back here. So it's returned here to O, displacement being 0. And I'm looking for the time. So just like we did before, I'm going to use s equal ut plus a half at squared. Sub in what I know, where s is 0, u is 15, t is what I'm looking for, minus 2.5 over 2 for a half a t squared. And again, I can use my calculator quadratic function to solve this one. And we should get that t is equal to 0, or t is equal to 12 seconds. Well, t is 0 was when the particle started at O, so t is 12 must be when it's gone all the way out and returned then back to O. So particle returns after 12 seconds. 12 seconds is my answer there. For B, it is a slightly different one. B is asking for the total distance travelled. But if we're talking about displacement, the displacement is 0 meters because it has gone back to where it started from. So I want to work out the distance. And to do that, I'm going to work out the distance from O to the very furthest point over here. And then I will need to multiply by 2 because it's gone out to that point, but then turn around and come back. So the displacement is what I'm after from O to this point over here. I'm going to call it A. So I'm looking for the displacement from O to A, and then remember I will multiply it by 2. I know the initial velocity, that's what they gave me, was 15 meters per second. The final velocity is the velocity at A. Now I can tell from looking at my diagram, the particle was moving and it was slowing down. It started at 15, it was slowing down, until it got to A, where it slowed down so much it started moving in the opposite direction. That must mean the velocity at point A was equal to 0. Because that is the point where the particle stopped moving in the positive x direction and started moving into the negative x direction. At that very point, the velocity was equal to 0. So here, I'm going to use my final velocity as 0 meters per second. The acceleration is still the same, it's still negative 2.5 meters per second squared. and the time I don't know and I don't need to worry about. So I'm looking for S, and I've got U, V, and A. So if I look at here, then I'm going to use equation 3. V squared equals U squared plus 2AS. I'll rearrange that to get S as the subject. S is equal to V squared minus U squared, all divided by 2A. So then I can put that in. So I've got S is equal to V squared is 0, minus U squared, which is 15 squared, all divided by 2, multiplied by A is negative 0.5. Type that into your calculator, and you get that the displacement is 45 metres. So I know from O to A is 45 metres. I've not completely finished though, because remember what we said, I need to multiply that 45 by 2. I'm looking for the total distance travelled by P to go out to A, but also to go all the way back. So my total distance is equal to 2 lots of 45. 45 metres to go out and 45 metres to go back in. And so that will be 90 metres is the total distance travelled by the particle P. Okay, now that we've worked through those examples, we've got all 5 suvat equations to use. You should be able to now have a go at the next exercise. So this one is quite a long exercise. I think it's exercise 9D, and there are a total of 15 questions that you can have a go at now.